Okay, let's dive in. We're going to talk about AH and K. I'm going to remind you of a couple things, and then you're going to see it within some problems that are exponential. Okay, so we're going to start by talking about this a times the base and then x or to the power of x minus h plus k. So let's write some notes. Now, I want to remind you that it is a good idea to write these notes, but that little setup is right there for you to see. Okay, so we're going to write it again. All right, so we have our a. I thought the marker worked better than that. Okay, time. We've got our base. That's part of the parent. Okay, and that's to the power of x. And then we've got our minus h. And then we've got our plus k. So our AH and Ks, those are the things that change. This base is not going to change. We have a couple different parents that we're going to use, but that's actually not going to transform the parent. It is part of the parent. So remember, our bases can be, we have a base of 2, we have a base of 3, there's a 4, there's a 5, and then we have the e to the x too. So you could see each one of these. It's not going to be all of them at once. It's going to be one of these. This is part of the parent. This is part of the parent. All right. So let's do a little reminder of what AH and K do. We did have a little bit of a review with that before we left when we were talking about the SLO, so it's probably not totally foreign. We did spend a significant amount of time on it in the fall, but just a reminder. So A, this is our A. We are going to either do a vertical stretch, so it is going to get skinnier, or it is going to compress. I think that the word that Big Ideas uses is shrink. Okay, shrink. That means it kind of like smushes. That probably wasn't a very good visual. Okay, sorry about that. Okay, the last thing it can do is that it can also reflect. Sorry, you can't see this over here. Let's move this over here. Okay, so and or it can reflect. Okay, so when did it actually do these things? Remember, it was a stretch when A was bigger than 1. And remember, ignore the sign, just look at the A. It was a compression if A was between 0 and 1. And it was a reflection when A was negative. Some kind of negative number. Or you could just write negative here and if you prefer that. Okay, so that's A. Let's talk about H. And I had that note on the other sheet, but remember, you have to switch the sign. So this opposite of H, that's actually what H is. It's the opposite of H. Okay, so this always moves things horizontally. And if it's positive, it's going to go to the right. And if it's negative, it's going to go to the left. And then there's our old friend K. And this is a vertical translation. So I wanted to make sure I use that word because I think Big Ideas uses that translation. So this one is a horizontal translation. And the K is a vertical translation. So if you recall, K goes up and down. So if it's positive, it's going to shift it up. And if it's negative, it's going to shift it down. But there is a new thing about K. See, you thought K was just so simple. Now it gets, more exciting as the year goes on. And that is, we're going to have that asymptote. See, I get to say it again, asymptote, asymptote. We have an asymptote. So I didn't really explain it in the other video, but an asymptote is an invisible barrier. I know it's not invisible, it's a dotted line, but we have to represent it in some way. It's an invisible barrier and a graph cannot cross it. So it kind of like keeps or kind of creates a barrier for the graph. And you'll see it in some of the examples, what they look like. Okay, so I have a horizontal asymptote and my equation for that horizontal asymptote is always y equals k. Now, I also put that in the actual notes itself. So if you forget, it's really important because it will ask you for the equation of the asymptote and you'll be like, well, this is what it is. It's just y equals whatever your k value is. Okay, so let's actually do some examples with this stuff. All right, so that means we can flip the page. Now, I want to remind you, you don't have to write all of this down. Just seeing some of the examples, especially at this part, may not be necessary to write them down. You can always go back and watch the video. Okay, so we are just going to start with a nice X and Y axis here, and I'm going to be doing some sketching. The ones that are in big ideas have like graphs on them, but for our purposes, so you can see the movement, this will be just fine. Okay, so I'm going to represent the parent in red. So all of our parents are going to look approximately the same. And I'm going to do 3 examples. So you know what? I'm just going to draw all those right now. And you can see my parent is already on there and all my parents look pretty identical, especially because these are just sketches. All right. These are just sketches. And so I made 3 of them. There we go. All right. And they all have that parent has a horizontal asymptote at 0. So there's that horizontal asymptote at 0. So I will draw that in. It's kind of hard to see over the black line. Okay. Our asymptote is going to move sometimes because, you know, as you can imagine, when we are changing k values and we're moving things up and down, the whole asymptote will move up and down. If we are moving things left and right, the asymptote actually doesn't change. It's still in the same spot. Okay, so let's actually see some equations. So notice how it didn't actually matter what our base was. They all look pretty similar. They all have that point at 0, 1. And they all start with that asymptote at y equals 0. Okay, so let's actually do a problem. So let's say that our equation is g of x, and we'll focus more on this one right now. G of x equals 2 to the x minus 5. Okay, remember we just use g of x because we need to show that it's not f of x anymore. F of x was the parent. This is just another version. It doesn't mean anything fancy. It's just the transformed function. Okay, so if we look at this, I can name my a, h, and k. There is no number in the front being multiplied, so my a is 1. A very common mistake is that people think 2 is your a. It's not. This is your base. That's your base. Okay, my h, if you notice, nothing is being added or subtracted up here in the exponent. So my h is 0. And then my k is this big one at the end. So equals negative 5. So we have no change to the a. We have no change to the h, but we have this change to the k. And we are going to go down 5. Okay, so this was our parent, and this right now is representing the parent y equals 2 to the x. And this whole thing is going to shift down. So the first thing I like to do, and you're not going to have to draw these, you're just going to have to look at the graphs on big ideas, is that we're just going to shift this whole asymptote down because, like I said, it's an invisible barrier. And so that helps me draw my new graph. So everything is the same, except everything just shifted down. So you are often asked for the equation of the asymptote, and as I mentioned before, y equals k, which means y equals negative 5. So the name of this equation is y equals negative 5, so it would be crossing at negative 5 down here. Okay, so that's one thing that can happen. That was a vertical translation down. Okay, so let's look at another one. This time, let's say that we had something like g of x equals e to the x minus 4. So that's in the exponent up here. Okay, so we're going to do the same thing we did before. Let's recognize our base. This is our base. Our base is e. And remember, I told you it's an irrational number like pi. It goes on forever and ever and ever. It is approximately 2.72. All right, so let's name our a, h, and k again, because you know I love doing that. I have no number being multiplied in the front, so that's a 1. Here is my h, and remember, we have to change the sign. So my h is actually 4, and I don't have anything being added or subtracted at the end, so my k is 0. So really the only thing happening to this one is that it is translating horizontally to the right 4. So you'll notice when I graph this, this asymptote is not going to change. My asymptote is still at 0. So I still have a barrier down here, except this whole thing is just going to shift to the right 4. So I'm just going to draw it kind of like over here. Okay. So there was a k change, there was an h change. Let's do the last one. And we're going to put the h and k change together. All right, so let's say hypothetically my equation is g of x equals, let's do 5 to the power of x plus 6. So that's all in the exponent because it's like little and like raised a little bit. And then I'll do plus 3 at the end. Okay, I know I didn't do any A problems. There aren't any, not that there aren't any. There are like 2 in the big ideas practice, and I think you'll be able to figure them out. So I'm not actually that worried. One of them's a reflection. I think it'll be pretty clear. So I don't have an A change. There would be a number in the front, so that's a 1. My H is going to switch signs. That's -6, and my K is a +3. So right away, I know my asymptote is going to be y equals 3. So that means this whole asymptote is going to shift up. So this is a shift up 3. This is a shift left 6. All right, so if I'm going to draw this, and again, remember, you don't have to draw these. I'm just showing these to you, and you won't have to draw them on big ideas either. I'm just showing these to you so that you can kind of get a gist of where the graph is moving. Okay. So I'm going to go -6 to the left, and then I'm going to go up 3. All right, so let's do our up 3 first, because that's going to just be right at y equals 3. So here's y equals 3. I know it's cutting through the parent, and I told you it was an invisible barrier, but this is an invisible barrier for the new one, not the old one. Okay, so this whole graph is going to shift up, and it is going to shift left. So it will probably be something like this. Okay, so your job now is to go and do the big ideas practice, and I want you to keep in mind to switch the sign on the H. Okay, I did examples 3 and 9. You can look at them on the paper. And then please contact us if you have questions, or if you didn't love this video, you can come see us do something very similar live on Wednesday, April 22nd.